Hey, good morning, guys. This is Unit 1, Investigation 2.1. So, hopefully you did well on the primetime quiz and you're good to go. And this is the next set of lessons in it. So, Investigation 2.1, and it's called Riding Ferris Wheels. Okay, so riding Ferris wheels. The focus question is, how can you decide when finding common multiples is useful in solving a problem? So what is a common multiple, what's a least common multiple, and what's a common factor and a greatest common factor? We're going to get into that right now. Common multiples, I'm going to give you examples because I think it's easier to understand what common multiples are. So a common multiple, let's say the numbers we have are 6 and 8. So common multiples are numbers that we could say 6 times 8 is 48. So we'll just start with 48. This is a common multiple. It's a product that both 6 and 8 fit into evenly. So 6 times 8 is 48, and 8 times 6 is 48. Now I could take this 48 and I could make it a little bit bigger. And I could double this 48 and I could say 96. Well, that's a common multiple as well of 6 and 8. And some of you smarter kids out there, maybe you're thinking, Mr. Cox, you missed one. You missed 24. I know 8 times 3 and 6 times 4 go in there. And we have 24. These are common multiples. So I guess the best definition mathematically wise, it would be shared. These would be the factors, and these are shared products of 6 and 8. So a common multiple is basically a product of two numbers that are shared. So it's a shared product. So it's going to be shared products of two or more. And I ran out of room, so I'm just going to put down here numbers. Or factors is what really is the better word, to be factors. So these are two factors. 6 and 8 are factors of 24, 48, 96. And those are products of 6 and 8. Now we come over here to least. So this is going to be the lowest common factor, lowest common multiple. Sorry. So which one of these is the lowest? Well, 24. So when we talk about the least common multiple, we look at two factors like 6 and 8, and we figure out what is the lowest number that 6 and 8 fit into evenly. And so in this case, it would be 24. So you can see right here, 6 and 8, LCM is 24. You may say, Mr. Cox, how do I know this is the lowest common factor? Well, the old-fashioned way, if you had Mr. Richmond, I know he likes this, you would just write out all the numbers. 6, 12, 18, 24, and 30. Okay? And then for 8, you would write out 8, 16, 24. And then when you see there are two of them that are shared, in this case the 24, there you go. It might be helpful if you have a multiplication chart with you so you can compare numbers quickly. So that's how we find lowest common multiple. I'm going to show you a different way after we understand this. It's a little bit fancier, but still get you the same answer. So the lowest common multiple is the lowest multiple is shared. Common multiples are basically not skip counting, but numbers like 6 and 8, numbers they share. There's a bunch of them that we could say that have common multiples 6 and 8. So there you go. Okay, so then what is a common factor? Well, factors, right, are like 6 and 8. Okay, and factors are what we multiply together to get products. So what is a common factor? And again, I think for me, thinking about common factors, I'm going to use the numbers 12 and 16. And I'm going to think about all the numbers that are multiplied together to go into my numbers 12 and 16. So for 12, right, the factors of 12 are 1, 12, 2, and 6, 3, and 4. Okay, and for 16, it's going to be 1 and 16, 2 and 8, and 4. Okay, so what are the common multiples that they share? Well, the common multiples in this case, I don't like that color, let's see if this one looks better, would be they share a 1, they share a 2, and they share a 4. Those are all, I keep saying multiples, those are the common factors, so 1, 2, and 4. Okay, and right over here, the greatest common factor is just the biggest one of these. Which one's the biggest? The 4 is the biggest. Okay, so greatest common factor is just Once you have all the common multiples, you just look for the biggest one. That's the greatest common factor. We're going to talk about why those are important in this lesson, but really we're going to be focusing on the multiples in this lesson. So the greatest common factor is the largest common factor. And we don't say largest, so I'm going to erase that. That was a good trick, wasn't it? I'm going to say greatest. So it just means the biggest. The biggest. And you can see we have the common for 12 and 16. We have 1, 2, and 4. It's just the biggest one. Okay. So we have some questions here. Think about amusement parks. We're not going to really talk about all that stuff just because we're getting to it. We're talking about a large Ferris wheel and a smaller Ferris wheel. And they're moving around at different speeds. And so we're going to have to look at the different speeds that they move and figure out when, like if this is the cart you're in right here, right? Let's say you're in this one right here. And let's say I'm in this one right here. How many times around do you go, and how many times around do I go until we're back at the bottom at the same time? That is a completely ridiculous question. Nobody would ever do this in real life. But we're going to use multiples, and we're going to figure out how many revolutions this needs to go based on the time, and how many revolutions this one needs to go based on time. And then we're going to find common multiples, right? Common multiples of numbers that are going around. Okay, so let me pause the video. Okay, so let's pretend that this large Ferris wheel, it takes 80 seconds to go around. So I'm just going to put 80 right here. Okay, that's one time around. That's pretty quick, by the way. And this one, the small one, takes 60 seconds. And that's pretty quick as well. When are both of these going to stop at the bottom at the same time? So how many times do you have to go around before they stop at the bottom? I chose these numbers because we already had 6 and 8. We already had some work. Okay, so if this goes around 1 time, 2 times, 3 times, 4 times, I'm using the word times because I really want you to think about it. I'm going to make a chart right here. Surprise, there's a chart there now. So we have a large and a small, and this is the times that they're going to go around. 1 time, 2 times, 3 times, 4 times, 5 times. And that's kind of interesting that we say times because that's actually what we're going to do. We're going to take, how long does it take for this big one to go around? 80 seconds. How long does it take for the small one to go around? 60 seconds. So pause the video, make your chart kind of look like this. You don't have to have this bottom thing down here, right? That's kind of a mess. Pause the video, make that chart, and then turn it back on. Okay, welcome back. So the large one goes around at 80, and the small one goes around at 60. And I'm just going to basically get rid of the 0. I'm thinking about this as the number 8. So I'm going to write out common multiples of 8. I'm going to skip count by 80s. But so I can do it in my head. It's going to be 16, 160, 24, 8 times, and it's 8. This is basically 80 times 1, 80 times 2, 80 times 3, 80 times 4, 400, 480, 80 times 7 is 56, is that right? 560, and 640. And these are all seconds, okay? These are all seconds. And same things here. So watch what I do. I'm going to do 12, 6, 12, right? 18, 24, 30, 36. Is that right? Yeah. 42 and 48. And I'm just going to add some zeros here. Because these are seconds, right? And now we have this little chart. And we're going to start looking for common multiples of when they're going to be at the ground, when these 2 Ferris wheels go around together. So we have 80. Nope, that doesn't work. 160. Nope. 240 works. There you go. Okay. 2300. 400. No. 40. Oh, there's 480. Okay, so we've highlighted what they share. In this case, we're really only concerned with the lowest one. So this is my lowest one right here. The lowest shared multiple is 240. So that's 240 seconds, right? I'm going to use my calculator, and I'm going to convert it over. So I take 240 seconds, and how many seconds are in a minute? Well, there are 60, and this is going to tell me how many minutes it takes. So it's going to be 240 seconds or 4 minutes, and that's how we do it. So we have some questions on the other side. Let's talk about that. You can review this again if you have any questions. Review the video. Otherwise, flip it over and we're going to go on. Okay, so we have 4 questions here. I'm going to go through the first one and hopefully set it up for you so you have an idea of how to do it. It says, for each situation below, how many seconds will pass before Jeremy and Deborah are both at the bottom again? So we're back to the Ferris wheels. So imagine those two things that spin around. You guys know what Ferris wheels, right? They're like have them at Disneyland and they have them at Knott's Berry Farm. And it's a ride that you go on and it goes up and around in circles. The large Ferris wheel goes around in 60 seconds and the small Ferris wheel goes around in 20. So what I did was I went ahead and made a chart down here. You can see I'm getting ready for it. So I'm going to call this one my large and my small, and I'm just going to put numbers up here. 4, 5, 6, 7, 8, 9. Now, these are going to be, across the top here is this fancy word, and it's right here, a revolution. And a revolution means to go around in a circle. These are the revolutions here. Sometimes they're going to ask for Sometimes they're going to ask for revolution or revolutions, and sometimes they're going to ask you seconds, and sometimes they may ask you minutes. In this sense, you can see right here, wheel 1 rotations, wheel 2 rotations, and then blank seconds are going to pass. So they want both, how many revolutions or rotations, and then how many seconds. All right, so here's all you do. The large one is at 60, so I would put that in here, 60, and the small one's at 20. Okay, and now I'm just going to skip count by these numbers. Okay, I'm going to start with 60. Okay, so it's 60, 120, 180, 24, right? 300, 360. I'm going to stop there because I can see already that this 20 is going to work out. So I'm going to skip count by 20s now. So it'll be 20, 40, 60, you see it, right? 80, 100. So we can stop right there. And we can highlight our numbers. Let's use the 60 seconds. And each one's, oh my god, I just did 40. Can you please not do 40? Not 40. Let me cross that out. Not 40. Okay, and so the big one goes around at 60 seconds. So that's the first thing we're going to add in here. It takes 60 seconds for them to go around until they're at the bottom together. The other thing that they're asking you is how many revolutions or / rotations, they changed their vocabulary on us, does it take? So it's how many rotations now. So when I look here, for the large Ferris wheel, it's 1 rotation. So I'm going to write that in here, 1. And for the small Ferris wheel, it's 1, 2, 3. So it's 3 rotations. Okay? So the large one is going to be the first one, and the small one is going to be the second one. And I would tell you to set these up the same way. I'm going to go ahead and set up B for you. Okay, so the large Ferris wheel makes 1 revolution in 50 seconds. The small is in 30. Okay, just because they're changing the vocabulary. I have L1, which is the large one, and then the small one 2 is the second one. So it's 50 seconds and 30 seconds. I'm going to skip count by 50. So it's 50, 100, 150, 200, 250. 300. If you probably carry it out probably 6 or 7 times, you'll be good. For 30, I'm hoping your little brains are firing. So for 30, 60, 90. Okay, I went out and wrote them out, and I see that it was 150 is where they meet. So the large one did 3 rotations, and the small one did 5 rotations. So once again, I look, 3 rotations, 5 rotations. The large does 3, the small does 5, and it was 150 seconds. All right, guys, that's the lesson. Finish it on out, and we'll talk to you in a bit.